Today's lesson is on Chapter 8, Section 2, Problem Solving. Alrighty, approaches to problem solving. People solve many different kinds of problems every day. Problems concern fitting things into a busy schedule or paying for what we need. Solving problems involves a series of processes, including analyzing the problem, breaking it into component parts, and establishing goals. Intermediate goals address parts of the problem that must be solved to arrive to that terminal goal, that is, the final solution to the problem. In many cases, people do not go straight from a problem to its solution in one giant leap. Rather, they move towards the solution in a series of steps. Ideally, each step taken moves the problem solver closer to the solution. But how people know what steps to take? If they do not know the solution, how do they know where to start? Through experience, people know that different types of problems must be approached in different ways. By simply identifying the type of problem it is, people have an idea of which method to use, which steps to take in solving the problem. All right, so some types of problems are best approached with the use of an algorithm. And an algorithm is a specific procedure that, when used properly in the right circumstances, will always lead to the solution of a problem. Many algorithms are more complex and time-consuming than simple formulas. And one example of an algorithm is following a brownie recipe. So if you were to follow the algorithm to create brownies from a box mix, you would follow the 3 to 5 step process in which the back of the box would state. So heat, stir, bake. This is a good example of what a algorithm would be, and here are your contents to make the brownies. But you would have to follow a certain steps in a certain order, and that's a good example of what an algorithm is. All right, heuristics. While algorithms are guaranteed to work, they are not always practical. This is why in many types of problems people use heuristics rather than algorithms. And these are rules of thumb that often, but not always, help us find the solution to a problem. They're shortcuts. They enable a person to discover or learn something for themselves. Heuristics are faster than algorithms, but they are not as reliable. An educated guess is an example of a heuristic that allows a person to reach a conclusion without exhaustive research. So most people use a heuristic. With an educated guess, a person considers what they have observed in the past and applies that history to a solution where a more definite answer has not been decided. Alrighty, problem-solving methods. Algorithms and heuristics are general approaches to problem solving. There's also specific methods of problem solving. Systematic research is one of these methods. Others include trial and error, difference reduction, means-end analysis, working backward, and the use of analogies. Trial and error. Trial and error is somewhat similar to systematic research, except that it is less reliable. Trial and error, we often do not keep track of which possibilities we have already tried. Sometimes we have to resort to trial and error in problem solving. If we do not know what our goal is, but we have absolutely no idea how to reach it, all we can do is try different things and see what happens with each one. And eventually we might arrive to our goal, but success is more or less by chance. So this is going to be trial and error. You don't know something until you try it. All right, difference reduction. In a method called difference reduction, we identify our goal, where we are in relation to it, and the direction we must go to move closer to it. In other words, we want to reduce the difference between our present situation, problem unsolved, to our desired situation, problem solved. So suppose you are standing blindfolded on the side of a hill. Your goal is to get to the top of the hill, but because you cannot see, you don't know which way to go. So what do? You take a step. If you feel yourself moving downward, you know that you're going in the wrong direction and you must change direction. But if you feel a pull in your legs, that means you're moving upward. And you know you're getting closer to the top of the hill and you have identified which direction to go in. So you're moving closer to your goal. All right, means end analysis. Another heuristic problem-solving technique is called means end analysis. In a means end analysis, we know that certain things we can do will have certain results at the end. Okay. Another method related to means end analysis. This technique, known as working backward, as in means end analysis, working backward involves breaking a problem down into parts and then dealing with each part individually. In working backward, however, the problem solver starts by examining the final goal and then works backward from that final goal to present a position to determine the best course of action. And this method is particularly useful when we know what we want to accomplish, but we're not sure how to get there. And working backwards helps ensure that we start off at the right path and avoid having to retrace the steps if we discover that the path that we chose does not lead to where we want to be. All right, let's see if we answered any of our questions today. All right, problem solving involves a series of processes which include what? Analyzing the problem, breaking it into component parts, establishing the goal. Number one is D, all the above. What is an algorithm? Let's see. Algorithm. An algorithm is a specific procedure that, when used properly and in the right circumstances, will lead us to the solution of the problem. That will not lead us. Okay. Is A, specific procedure that, used properly in the right circumstances, will always lead us to the solution to the problem. A. Number two is A. What are heuristics? Heuristics are rules of thumb that often, but not always, help us find the solution to the problem. They are shortcuts. Okay, B. So 1 is D. 2 is A. 3 is B. And number 4, what does flexibility mean? Okay, we haven't gotten there yet. All right, continuing with our lesson. All right, working backwards. All right, analogies. Some people solve problems by analogies. This is a similarity between two or more items, events, solutions. When people have successfully solved one problem, they may try to use the same approach in solving another problem if it is similar enough to the first one. All right, obstacles to problem solving. Sometimes we have trouble finding the solution to a problem simply because the problem is difficult, or perhaps because we have little experience in solving that problem. At other times, particular obstacles get in the way of us solving a problem. And two of these obstacles are known as mental set and functional fixedness. Okay, so mental set. People often try to solve new problems in ways that work for similar problems. The tendency to respond to a new problem with an approach that was successfully used with similar problems is called mental set. While mental set can sometimes help us solve a problem, it can also sometimes get in the way. A mental set is an unconscious tendency to approach a problem in a particular way. Our mental sets are shaped by our past experiences and habits. For example, the last time your computer froze, you restarted it and it worked. That might be the only solution you can think of the next time it freezes. Now, functional fixedness is another obstacle to problem solving. Functional fixedness is the tendency to think of an object as being useful only for the function that the object is usually used for. Functional fixedness is a type of cognitive basis that involves the tendency to see objects as only working in a particular way. For example, you might view a thumbtack as something that can only be used to hold a paper to a corkboard or a bulletin board. All right, problem solving and creativity. Functional fixedness can often be overcome by creativity, the ability to come up with a new or unusual ways of solving a problem. Creativity requires divergent thinking rather than convergent thinking. With convergent thinking, thought is limited to available facts. With divergent thinking, however, there are many options and possible solutions to the problem. The various leads run in many directions. Perhaps one of them might lead to the solution. And sometimes successful problem solving may require both divergent and convergent thinking. At first, divergent thinking produces many possible solutions, and convergent thinking then helps us select the most probable solution and to reject the others. Alrighty, flexibility. Flexibility is the ability to adapt to new, different, or changing situations. Sorry. Alright, so flexibility, the similarity between, nope. Alright, so flexibility, number 4 is B, the ability to adapt to new, different, or changing situations. All right, so let's say you're at a party and a person shows up to that party that wasn't supposed to, and you don't like that person. A person with high flexibility would adapt to the situation and take their anger and negative emotions and reconfigure them and realize that their emotions were not important enough to cause a scene at the party. So if you balance your needs, you can discreetly leave the party or that atmosphere at a good time. So the next time you get stuck on a problem, just ask yourself if you could be more flexible with your approach. And flexibility may allow you to come up with a creative solution. Recombination is the mental rearrangement of elements of a problem. All right, so for example, music is made up of notes arranged in a scale, but the combination of those notes creates distinctive sounds. The same notes could be recombined to a sound like a completely new piece of music, and all a composer needs to do is use a different rhythm, different types of instruments, softer and louder tones. These are all examples of involved recombinations of familiar elements. So, I mean, most music is just a series of notes and scales, and if you're recombining some of these notes and scales in different orders, you're being creative and you're recombining some of those notes and scales to make up a new piece of music. All right, insight and incubation. Have you ever pondered a problem for a while, then the solution came to you suddenly? Did it come to you in a flash? When this happens, we've experienced insight. And often we express our delight and surprise by examining aha, or something similar. As a result, experiences of insight are also known as aha experiences. Sometimes we need to get away from a problem for a while before the solution comes up to us. When we arrive to the solution to the problem we have not been consciously working on, we've experienced an incubation effect. And one type of incubator warms eggs so they will hatch at the right time. Incubation is a problem-solving means standing back from a problem for a period of time while the unconscious process within us continues to work. Later, the answer will occur in a flash. It will have hatched on its own. Okay, and because of the incubation effect, psychologists sometimes recommend that people take a break from work when they're trying to solve a difficult problem. So I like go for a walk, call a friend, but like just after taking a mental break, you might come back to that problem refreshed and have a new point of view to the approach that you might have developed with taking that break. So it's always good to take a break if you can't solve a problem. All right, so that ends our lesson today. Let's go back and answer that last questions. What does insight mean? Pondering a problem for a while and having the solution come to you suddenly. Aha experiences, all the above. Number 5 is all the above. So get your answers to me. I'll put them in the description below, or you can send the answers to me in an email. All right, that's the end of the lesson. Peace.